Welcome to Frequency Matters, the RF and microwave update. I'm Pat Hindle and I'm here with my co-host Gary Lerude. In this episode, we're going to continue our coverage of the July software and design issue. And as a reminder, the cover story is about 5 of the major leading EDA platforms, and they talk about how they're using multiple solvers and tools in one environment. So it's really making life easier for the engineer to be able to solve in thermal, electrical, and all different types of solvers.
Right.
But we didn't cover the products last time, so what do we have for product features?
So we have 3 product features. The first one from Rohde & Schwarz, some new signal generators. They have a couple variants. One is an analog, one is vector. Basically, otherwise have a lot of the same performance. They have the option of going from 8 kilohertz, either 1, 3, or 6 gigahertz, and then also, interestingly enough, different power levels. So they have the option to go to a higher power level. So in many cases, if you're testing a power amplifier, you'd need a driver amplifier. Now, with the high power option, you don't necessarily need that. So that's from Rohde & Schwarz. We have Anoki Wave. They've released something they call their intelligent gain blocks. Those are pretty interesting. They have 2 configurations. One is a PA, an LNA, and in both the transmit and receive sides, they have independent amplitude and phase control. And then the variants are, in one case, they have a TR switch at the antenna and a TR switch at the other end. The second variant, they've taken the TR switch at the antenna off. So you have 2 separate, if you will, an input to the LNA, output for the transmitter.
Yeah, giving a lot of flexibility to the designer.
And the other option is they cover 2 bands. So there are variants for the 10.5 to 16 gigahertz band and then the 26 to 30 gigahertz band. So KU band and then KA band for obviously 5G type applications or satellite communication. And then our third product feature is from ComSol. This is interesting. They've added the 2D axisymmetric EM modeling capability to their RF module, and this simplifies EM modeling if you have a geometry that's symmetric. And obviously doing that, it simplifies the model, but it also speeds up the computation time.
Yeah, they can solve for part and just multiply the other.
Right, in effect, yeah. So those are our product features. How about tech briefs?
So for tech briefs, we had 2. One is a 5 to 1218 megahertz 8 dB coupler with 40 dB isolation, and that's from Mini RF. And we also had a cable and antenna analyzer covering all the cellular bands from Kalis. We haven't heard from Kalis in a while, so it's good to see that in there.
Yeah, that's an interesting product.
So now we have a special clip from an interview we did earlier in the year. I was at Virginia Diodes and I talked with Dr. Eric Brierton, and he was working on a project with NASA. And what this did is they developed an 833 gigahertz radiometer, and it went on a CubeSat. They did it with COTS materials. And what it does is it measures the level of ice crystals in the clouds, and that's used for weather forecasting.
Interesting.
This whole thing was a proof of concept to try to see if they could do a solution to this. And we'll take a look at just a clip from that video now. And so you have some of the components here. Can you tell us, what type of circuitry and devices go into making up this product?
Yeah, certainly. So this is a mock-up of a the ice cube science plate. So it was a 3U CubeSat where each U is a 10 by 10 by 10 centimeter volume. And the actual front end, the receiver part, the millimeter wave part, needed to fit on this 9 by 9 centimeter plate and take up about 2.5 centimeters height. So there's a few kind of critical technologies, challenges in something like this. So it's a heterodyne system, and a heterodyne receiver at nearly a terahertz is a huge consumer of DC power, because you have to generate a local oscillator up near a terahertz with a few milliwatts coming out of it to drive the Schottky mixer. So to do that, you would traditionally start at a low microwave frequency, 12 or 15 gigahertz from a DRO in this case, and then amplify it, multiply it, amplify it a lot, and then go through successive stages of multipliers, each one with just a few percent efficiency. So one of the developments that VDI had from actually a previous SBIR contract with NASA was to develop a set of very high efficiency varactor multipliers targeted specifically to these critical atmospheric windows. So we had these high efficiency varactors which lowered the overall DC power that you needed to start with. So that was kind of the critical technology one. Number 2 is having the highest possible frequency power amp, so that you're because your power amp is generally going to be more efficient than your conversion efficiency of your multiplier. So having this new, and this is not VDI technology. This has been developed for military applications and for new comm applications such as 5G. Having these amplifiers in the E-band range with 100, 200 milliwatts of power with pretty good power added efficiency. So starting with that and then going to these high efficiency varactors at sub-millimeter waves allowed us to have this Schottky receiver with just a few watts of DC power.
And that was just a portion of the interview. You can see the full interview online in our video platform, which, speaking of our video platform, we have a brand new one. You should check it out.
It's nice.
It's a whole new format, and we've reduced the price of our video program, so contact me if you have any interest in those. Virginia Diodes is a very interesting place. We did a Fabs and Labs earlier.
Right.
And we did this interview. If you're looking for products in the hundreds of gigahertz up to like 1.5 terahertz, they're kind of the only game in town. They do a great job.
Yeah, they have a lot of interesting products, and it's hard to imagine some of the applications at those frequencies.
And so turning to the news, T-Mobile announced that they've deployed a NB IoT network throughout the US. And according to the company, it's the first one that uses LTE guard bands for optimal performance. And they also announced the T-Mobile Connect Partner Program that will allow companies to collaborate to produce new products and services. And also this NB IoT network is a lot cheaper than the Cat-M programs that are offered by other competing companies now. So that's a big reduction in price. And they also talked about how Qualcomm modules, their LTE IoT modules, are certified on the network. Speaking of Qualcomm, quite a bit of news surrounding them. They announced some RF products, but bigger news that we just learned this morning was that the whole NXP merger is off.
Right.
Seems like China has kind of crushed that because of retaliation for the tariffs that the U.S. has imposed on them.
Yeah, the Chinese government apparently said it only had to do with anti-competitive concerns, antitrust concerns, but of course you can read the tea leaves and draw your own conclusion. But Qualcomm has basically said they're going to now, as Plan B, take $30 billion and buy back stock and focus on the company. They feel like they have lots of good growth opportunities and can do just fine standalone. Of course, NXP has kind of been on hold for almost 2 years now, waiting for this deal to happen. They've had a very low profile, at least we've seen in the RF microwave space, so I think they probably have some catch up to do to get back into the game.
Well, it's good to put it into this so they can go on their own way.
Right.
And Strategy Analytics made some comments that they think the outlook is pretty good for both companies despite this not going through.
Right, exactly. I don't know from a financial analyst standpoint, maybe you have higher expectations in terms of returns, but I think from a technology product standpoint, both companies are in pretty good shape. And speaking of that, you mentioned Qualcomm. They had quite an interesting announcement earlier this week of some 5G modules, both covering the millimeter wave band and the sub-6 gigahertz bands that have been identified for 5G. So the millimeter wave, what they call antenna modules, actually integrate the new radio transceiver, a power management IC, an RF front-end components, and a phased array antenna, all in a little module that kind of fits between your fingers. They have support for the 26.5 to 29.5 gigahertz band, the 27.5 to 28.35, and the 37 to 40 gigahertz bands, which are all designated 5G bands. Then for the sub-6 gigahertz, they introduced 4 modules. 2 of them have PA, LNA, switch, and filtering. And then 2 are the same, except they've taken out the PA. So those are more for the receive side, what they say, diversity receive and MIMO, massive MIMO. And these particular modules, they have configurations for the 3.3 to 4.2 band, the 3.3 to 3.8 band, and the 4.4 to 5 gigahertz band, which are designated, again, 5G bands. So it's pretty interesting. They're out of the gate with what looks like some pretty impressive products.
Yeah, very comprehensive.
And particularly at millimeter wave, it's probably the most integrated I think we've seen so far. So what's on your travel schedule?
So the next event I'll be attending is the IEEE EMC SIPI conference in Long Beach. So if anybody's going to be there, look me up. And how about you?
So I'm going to take a few days off, but otherwise I'm staying close to the office for the next issues that we're working on. We do want to remind folks that EDICon, our Electronic Design Innovation Conference, registration is open now. That is scheduled for October 17th and 18th in Santa Clara, California. That's a Wednesday and a Thursday. I think we're pretty excited that we have what we call EDICon University. So both those 2 days in the morning, we have 3 different courses that you can choose from. So 3 on the first day, 3 on the second day. And the latest news on that is people who attend can get the IEEE Continuing Education Credit.
Yeah, I think we've really done a good job on having training courses, workshops, panels, and sessions all in one place.
Right, exactly. And the actual training sessions cover both signal integrity and RF microwave. So you should be able to find something there that will give you a benefit and give you some new knowledge to take back to your companies. And I think that wraps it up. So not as much fun this time. We're not out on the beach, but nonetheless, we want to thank you for watching. We appreciate your support through Frequency Matters and hope you're enjoying the summer. Until next time.